Hello, trig kids. We're down in the basement of the Larson house going to do some trig today. First of all, joke of the day. See if you can get this one. What is a math teacher's favorite pet? What is a math teacher's favorite pet? The python. Yes, the python. Okay, let's get rid of the python. And let's do a little trig today. So, put this down here to begin with. 7.4 trig functions of any angle. So we're going to expand our horizon more than 360 degrees. And I'll show you how to figure those out without a calculator. And also find trig values with a given point. So now we're going to start thinking about how the XY coordinate has to do with making a triangle and getting some trig functions. So, first problem here. Let's think about what if we had a point that was 3, 4. Well, let's plot it over 3 up 4, so it's about right here. 3, 4. What we're going to do is we're going to make a triangle, a right triangle, going back down to the x-axis. Don't take it up and go to the y-axis, to the x-axis. So right in here is going to be our angle measurement. Well, if we're at 3, 4, we had to have gone over 3 and up 4. And we probably would want to know what the hypotenuse is, so we can do all those trig values. Pythagorean theorem tells us 3 squared plus 4 squared equals 5 squared. Hopefully you know that one. So now we are going to do sine, cosine, and tangent. I will say this, in the book they will ask you to do all 6 trig functions. You just need to do sine, cosine, tangent. So you don't have to do secant, cosecant, and cotangent. Alright, well now you're in this corner right here. Opposite over hypotenuse would be 4 over 5. Very important to label them. I think it really helps. So that would be 4/5. Cosine of this same angle, now it's adjacent over hypotenuse, 3/5. And then tangent would be opposite over adjacent, get that order right, which should be 4/3. Okay, notice these are between -1 and 1, which you found out on your graph that you did on your other assignment. Remember the trig values of sine and cosine go from +1 to -1. Tangent can be all over the board, and we'll see that later. Okay, let's try another one, but let's not be in that first quadrant. Let's be in, I think I have an example of us being in the second quadrant. -2, 5 will be our point. Hopefully you can see this. So -2, 5. That would be over 2 and up 1, 2, 3, 4, 5. So it'd be about right there. There's that point. 2, 5. Oh, draw that over a little bit further. There, like that. So how do we make that triangle? We go from the origin out there and come back to the x-axis. Now here's the tricky thing here. Yeah, this is 2 units, but we've gone backwards, so that's -2. We're going up, so that's still 5, and now we have to figure this out. It's not a great number. -2 squared plus 5 squared equals the hypotenuse squared. Well, this ends up being 29 is c squared, so we actually get the square root of 29. Just leave it like that. That's 5 point something, 5.23 or 4, something like that. But just leave it as the square root of 29. So here we go. Sine of our angle measurement, which is always going to be right there. Cosine, tangent. Okay, sine. Oh, I better put this in here. And one thing, the hypotenuse, or we sometimes call this the radius, that will always be positive. So that's always positive. If you're going this way, that's going to be negative. If you're going down, that number, the opposite number would be negative. Okay, so opposite over hypotenuse, 5 over the square root of 9, just 29. Just leave it like that. This next one is actually -2, that's the adjacent, over the square root of 29. You can put the negative out front if you want, or you can put it with the 2 to help you out. And tangent would be 5 over -2. Again, if you wanted to put it like that, you could. Probably don't make it negative 2.5. Leave the fractions in there. Okay, so you'll have a few of those problems. You have to just do sine, cosine, and tangent. Don't worry about the other inverse functions. So that's kind of what we did right up there. Now we're going to deal with some angles bigger than 360, and we'll see how we can attack those. Let's first start off with the sine of 390. And the one thing we're going to find out, the sine of 390 is the same as the sine of really multiples of 2 pi, multiples of 360. If you take 360 off of that, you get 30. These two are actually the same. You can check that on your calculator and you'll see that. So really what we want to do is we want to go to this because we can draw this. This is a little harder to draw because this would be all the way around like that. So we'd rather just go to this one. So we just kind of have what's called a reference angle. We've got this 30 degrees right in here. So again, come straight down here. And then use your nice numbers, 1, 2, square root of 3. And, you know, this will be positive over here. But if we were over here, you have to take care of whether it might be negative or not. This would be 1. Hypotenuse is 2. And this is about 1.7, which is the square root of 3. Okay, so now we got everything we need. There's actually one number we don't need. We don't need the adjacent, really. But it's okay to put it in there. So opposite over hypotenuse would be 1/2. So the sine of 390 is 1/2, which is also the same as the sine of 30 degrees. But the question is asking this one right here. Let's try another one using, I think, cosine. And instead of having in degrees, we're in radians. So we have to account for that. Cosine is going to be more than 2 pi. So cosine of 9/4 pi. Okay, little practice on what that is. Well, first of all, if you wanted to, it's bigger than 2 pi, so it's bigger than 360. We could just take 2 pi off of that. We could convert this into degrees and then take 360 off of it. I just am thinking this is 2 1/4 pi. I'm going to take away 2 pi, so that leaves me with 1/4 pi, and hopefully we all are going, oh yeah, that's 45 degrees. So I will draw 45 degrees is in the first quadrant. 45, come back down to the x-axis, make my right angle. Probably put my 45 to remind me that's the angle that's the corner I'm in. Going up, that's positive. Going to the right, that's positive. And this is always positive. 1 square root of 2 is my 45. So this 45 is called a reference angle in this case. Now we go back. What are we doing? Cosine. Cosine is adjacent over hypotenuse. So the answer to both of these would be 1 over the square root of 2. Now remember, in the back of the book, since mathematicians don't like a square root in the bottom, we rationalize it. You might actually see it like that. These two things are the same thing. I'm okay with you writing it this way, but if you look in the back of the book on something, you're probably going to see it this way, just so you know that. Let's try one more. And it's not going to be sine, it's not going to be cosine, it's not going to be tangent. It is going to be secant. Secant of 585 degrees. So what is that ratio? Well, 585 is too big. Let's take 360 off of it. Because remember, whether we go around, how do I want to do this? You go around and end here, or if you just have this, it's the same thing. So we can take multiples of 360 off. We take 720 off if it was a really big number, but we're going to get secant of 225. Now that seems pretty big too, but it's less than 360. So 180 plus 45 more puts us in that third quadrant. Our reference angle right there is 45 degrees. So, and maybe you feel better if you take this away once we have it drawn. This is what we got going on here. This is the right triangle, that's 45. 1 square root of 2. Be careful here, 1 square root of 2. Not quite right because we went to the left, so that would be -1. And, and this can be -2, also. -1, also, because it's down. So Went to the left and went down. That's why that's negative, and that's why that one is negative. Now we'll go, okay, secant of 225. And off to the side I might be thinking, okay, cosine is adjacent over hypotenuse, which means secant is hypotenuse over adjacent. Hypotenuse is square root of 2. Adjacent is -1. So basically, -1.444 would be that answer. Right there. For both of these, you're being asked this, but you kind of use this to help you out. Okay? So, kind of two different types of problems. One, you're dealing with where, a point on the coordinate system, and you draw a triangle, and you come up with the ratios. Here you have something bigger than 360. Shrink it down so it's less than 360, that coterminal angle. It ends in the same spot, therefore it has those same ratios. And just play around with your calculator. Put in sine of 47, and then put in sine of 407, because that's 360 more. You should get the same answer on that, and kind of helps you out there. The assignment that you will have, I'll just write it down here, 11 through, this is on 7.4, 11 through 17, do all those, and 21 through 24. Remember, on these, you just have to do sine, cosine, and tangent, not all the other stuff. And here you're just coming up with one ratio for each one. All right? Thanks for listening. Good luck. Stay safe. And we'll catch you later.